let's go back to here. You've got to be able to do domain, and this is at least the second time we've seen it, maybe not this semester, but you saw it last semester, saw it in Algebra 2. The expectation is you nailed it. All right, so you should be able to look at this and without even hesitating. If you have to hesitate, if you have to think, then you need to go back and study your notes. There are two types of issues, and two types of issues only. There are negative issues, and there are zero issues. All right? Negative issues are even roots. Your zero issues are variable in the denominator. So this should be easy to identify. We take care of even roots. We have to do a table only for evens. For the zero issues, we take care of it using parentheses. So if we go to this one, what kind of issues do we have? Negative, which means it requires a table. So you're going to take the radicand, which is what's underneath. You're going to set it equal to 0. And Connor's going to factor. Go ahead, Connor. I'll get you started.
So you'll get -6 and -2. So, yes, that's fine.
Okay, they have to both be negative for 12 to be positive. -6, -2 gives me -8. So x is equal to 6 and x is equal to 2. Now the expectation is that you can draw the appropriate table. All right, if you do not draw, if this is a domain question and I do not see a table, then you're not going to get any credit from here on out. So if we look at this, and if you're new to this, we've got 2 and we've got 6. This separates the number line into 3 pieces. We've got -infinity to 2. We've got 2 to 6, and we've got 6 to infinity. Now we're going to pick test values like 0, 3, and 7. And then we're going to take, I'm going to choose the factored form. And I need to see this table filled in. That way, if you make a silly mistake in the table, I can figure that out. 0 subtract 6 is negative. 0 subtract 2 is negative. Negative times negative is positive. 3 subtract 6 is negative. 3 minus 2 is positive. Negative times positive is negative. 7 subtract 6 is positive. 7 subtract 2 is positive, so that is positive. Negative issues mean we eliminate that which causes the negative. So now my domain is going to be -infinity to 2, and then 6 to infinity. Do we use a parenthesis or a bracket? It is negative issue only. It is not a zero issue. Therefore, we use a bracket, Gabby.
Why do you have like x minus 6 1 and x minus 2?
Because are these being multiplied together to give me this, which is totally under one radical? Okay, a single radical goes on a single line. Even though there's pieces to it, it was multiplied together. If you're going to talk, I'm going to quit. I got lots of work to do. This is your test grade, not mine. This is your college GPA, not mine. All right, let's look at the next one. What kind of issues do we have down here? Okay, the zero issues are because of the denominator, not because of the numerator. We're going to take our 9 minus x squared and set it equal to 0. 9 equals x squared. X is going to equal plus or minus 3. So, negative issue or zero issues do not require a table. We take care of zero issues using parentheses. Parentheses will exclude those values from your domain. So you've got 2 of these on your test. You need to know how to do both. And they're going to compound themselves in the operations and in the, so if you, whatever you don't know how to do, video notes are online. They are labeled by topic, so they're easy for you to figure out which ones you need to watch. So there's no excuse for anybody not doing well tomorrow, unless it's lack of effort on your part. Because what did we decide earlier, Michael? It's certainly not a lack of effort on whose part? Thank you. Okay. Desmond, did you hear that? Okay. So, now you've got operations of functions, all right? And you have composition of functions. And you have to do the domain on both, okay? You've got operations and you've got composition. And the way you attack this domain is differently. So on the operations of functions, the first thing you have to do is determine this domain. You have to determine this domain, and then you have to determine the intersection of the two domains. Intersection of two domains. Any questions? That's where you start. And this is going to be the domain until the operation changes it. So if I look at this, what is this domain? Negative infinity to 0. 0 to infinity. We have 0 issues because there's a variable in the denominator. What is this domain? Okay, so what do these two domains have in common? In other words, what is the intersection? Is this the intersection? Is this the intersection? Okay, what they have in common. The only thing they don't have in common is what? The 0. That's the only difference between those two domains. Now, that's the domain that we're going to work with, and that's going to be the domain for every operation unless after you do the operation it introduces new issues. Yes, ma'am.
What if we did that at the end? We got the same answer. Is that like...
I'm just saying that depending on the problem, you could run into problems if you don't do it this way. All right, so now, f of g of x in its domain. How do I do f of g? We put 3 over x over 4x minus 5. Do you leave it this way? No. How do you fix that? So we have 3 over x times 1 over 4x minus 5. So we have 3 over x times 4x minus 5. Now, did we generate new issues? Okay, there are new what? 0 issues. All right, we've already taken care of this issue, correct? So now, what else must I do? We take 4x minus 5, we set it equal to 0. 4x equals 5x equals 5 over 4. So now, what do I have to do? Correct. You need to exclude the 5/4 in addition to the 0 that was already excluded. All right, this may seem silly, but I can tell you that last year when I didn't teach it this well, the answers in back of the book were not matching the answers that kids are getting on their papers. So if you decide to go forget all the beginning, then you can run into trouble because that's the issue. I just did the end. I didn't look at the beginning. Okay? Any questions on operations? All right, so shall we go to the homework? Okay, what questions do you have on homework? 87 said?
F of x equals 4x minus
4x minus what?
4x minus 3.
Okay. Is this an AB?
Yeah.
Okay, this was the AB that nobody did the B on, that you have the B on your test. All right, to find the inverse, the first thing you do is change f of x to. The second thing you do is to. So I have x is equal to 4y minus 3. The third thing you do. So I have x plus 3 equals 4y. Or y is equal to, now I'm going to choose to do 1/4. So I'm not going to have a complex fraction. Now, the last thing you do in the final form I want to see I don't want to see a y. I'll take off a point if you give me y. I need inverse notation. That's the final answer on part A.
Wait, will you accept it if we put x minus 3 over 4?
No, because it's not x minus 3 over 4. It's
Or
x plus 3.
X plus 3.
Yes, I will accept that. So now what do you have to do on B? The test will say using composition of functions. I will not give you as much as those directions give you. Using composition of functions, determine if the functions are inverses. That's what my directions will read. So what they asked you to do is they asked you to do f of f inverse of x. What does that mean? You take your f function, you prepare it for substitution. What am I putting inside? 1/4 times x plus 3. What happens when I multiply 4 times 1/4 times x plus 3? It's going to what? What's x plus 3 minus 3? X. So is this good? Yes. Now what else do you have to do? You have to do f inverse of f. So now you're going to take 1/4 plus 3, and what are we substituting in its place? What's f? 4x minus 3, and what do the 3's do? What's 1/4 of 4x? X. Page.
So you put what got at first in the original equation?
And vice versa. However, I'm not going to run these two together. This will be a standalone question. I will give you an f function and I will give you a g function. So you'll do f of g and g of f. Okay? That way, if you messed up on your inverse, then that compounds that process. So I made it a standalone. Next question on the homework. That was the only question? Yes, page 85. 85 said,
I don't have it much, just f of x equals 3 over 5x plus 1 half.
like this, right?
Yeah.
And g of x?
Is 5/3 x minus 2.
And didn't they ask for g of f and determine inverses, correct?
Yeah.
So this is what mine will most likely look like. So you have to do first f of g. So what does that mean? I'm going to take my f function and I'm going to prepare it for substitution. Now what do I put inside?
5/3 x.
What did the directions say? Determine if they're inverses?
Yeah.
Or did they say find f of g and g of f?
F of g and g of f.
So we have to do both.
Yeah.
Okay. So I'm going to distribute and I'm going to get 15 over 15, which is x. Multiplying fractions, top times top is 6, bottom times bottom is 5 plus 1/2. Now this requires that you get a common denominator. Why can't you eliminate denominators? Why can't we eliminate denominators? It's not an equation. What did we multiply 1 by to get 10? So that's going to be 10x. What did we multiply 5 by to get 10? So that's going to be minus 12. What did we multiply 2 by? So that's going to be plus 5. Or 10x minus 7 over 10. What else could you have? I think you could have had x minus 7/10. Okay, that's f of g. Now, if I'm asking you if they are inverses of each other, would you go any further? No. Has this already failed?
Yeah.
To be inverses, what does this have to be? However, that's not what they said. They said find them first. You with me?
Yeah.
So now you have to do g of f, and I think this is worthwhile because of the fractions. So now we're going to take the g function, and we're going to prepare it for substitution, and in this place I'm putting 3/5 x plus 1/2. Okay, so 3/5, we get 15 over 15 again. Now we're going to get 5/6 minus 2. What's a common denominator for my common terms? 6. So this is going to be 5 minus, we multiplied by 6, 12, or we're going to have x minus 7, 6. That's g of f. Are they inverses? No. Okay, what's next? Next. Oh, I distributed the 5 here, and it's top times top, bottom times bottom. Okay? Other questions? Okay. So then my next big concern is our composition of functions and the domain. I'm not concerned about you composing them. I'm concerned about the domain. So when you have operations, you start with both domains. When you have composition of functions, you start with which domain? The which one? The inside function only. And how do I look at this and determine the inside function? G. So I need this domain. So what are the issues here? Negative. So you're going to say x minus 5 equals 0, x equals 5. What's required for negative? Negative infinity to 5, 5 to infinity. How about 0 and 6? These are my test values. What's 0 minus 5? And 6 minus 5. So currently our domain is 5 to infinity. What goes around 5? A bracket. All right. So now we're going to do the composition. How do I compose this? F of g. What do? I prepare which function? F. So what goes underneath? G. All right. Have I introduced, are there new issues? Now we have 0 issues that we did not have before. Do you see how we did not worry about that x being 0? We didn't worry about it. It's all about the inside. All right. We have 0 issues. What has to be excluded? What do we exclude? 5. So instead of this domain, what is my final domain? How do I exclude 5? Parenthesis 5 to infinity. 2 different ways to do the operations and the composition. All right, you have the benefit that I taught this well this year. I taught it awful last year. I failed miserably. Okay? But I was determined to do better this year. Now, determine if these are inverse functions using composition of functions. Did we already do one like that? Yes. So we don't have to do that one. So let's go back to our objectives and see, because that's all I wrote. Did anybody bother to go back and look at this one that I told you on page 291? Uh-huh.
I did those.
I think you were the only one. Okay, I'm just saying, you better review. All right, were you given a graph in the, yes. You did have it. You had to graph a function, then graph its inverse, etc. The good news is I will give you the graph. You don't have to graph the original one.
Wait, I had a question.
How to graph 1 minus x squared? Okay, that was x greater than or equal to 0. So they restricted your domain, so that tells you should do 0, 1, 2.
Yeah, I was looking at the table, and then I'm just like, how do I graph this without any...
So you do 1 minus 0, 1 minus 1, 1 minus 4. Did I do that right? What's the one way that you can always graph? Using a table. All right. So now remember, we're only graphing, they restricted our domain for a reason. So now we're going to graph 0, 1, 1, 0, and 2, 1, 2, 3. So this is our, and it keeps going, correct? Okay. Now, how do I take this graph, which is yours, you will start with tomorrow, and how do I do its inverse? You flip this ordered pair. 0, 1 becomes 1, 0. What does 1, 0 do? Becomes 0, 1. What does 2, negative 3 become? So now this one's going to go like that. So what is the domain of the green? Because I'm going to ask you the domain of the inverse. To 1, included, right? What's the range? Lowest is 0 to infinity. Now, is the inverse a function? Yes. The green is a function because we see it and it passes vertical line test. Now, if I had not had you graph it, what would you have said? Yes, because it passed the horizontal line test, because the horizontal line is done to the original. All right, any other questions? All right.